Okay, at number 34, they tell us they have a sample space that only has 4 different outcomes, so that's the only 4 things that could possibly happen. They tell us that the probability of the first 2 is equal, added together, is equal to the probability of the second 2 added together, and then they tell us specifically the probability of the first one. So, and then they ask for the probability assignment for the space when O2 and O3 have the same probability. So what they want at the end of this is for us to tell them the probability of each one. So we already know this one is 0.15. We want to know what's the probability of the rest of them. Okay, so one thing, whenever they tell you something concrete, like a number, you can plug that in. So instead of probability of outcome 1, I can just put 0.15 in that equation. I know that that's the same. I'm going to use P for probability instead of PR, just because it's faster to write. So here's what we know from the question here. Then they also tell you that outcome 2 and 3 have the same probability, so they're equal to each other. If 2 things are equal to each other, then they're interchangeable. So that means over here, let's say where I have O2 or O3, I could write them both down as O2 or O3. It doesn't make a difference which one I pick. So let's say if O2 and O3 are the same, there's no reason to have 2 different ones. We'll just call them both O2, right? If it's equal to it, if they're the same, they're interchangeable. All right, so then if we look at this as an equation, see how if I subtract the probability of outcome 2 from both sides, that goes away. So I have 0.1 for this cancels, it adds to 0. So probability, whatever it is, could be 0.7, could be anything. If I subtract it from both sides, then I'm left with just these 2 pieces of information. That's kind of nice because that's telling me straight out away that probability of outcome 4 is 0.15 or 15%. So I have another piece to the puzzle. All right, what else do I know all the time about probability spaces? Well, if this is all the possible outcomes, then all the possible outcomes should add up to 100%. And so as a probability, 100% is 1. So I know that these all add up to 1. Well, I know some of them already. Like I know this one and this one are both 0.15. And I know something else about these. I know these 2 are the same. So instead of writing outcome 2 and outcome 3, I could call them both outcome 2, or in this case, let's call them both outcome 3. They're the same, so they're interchangeable. So it looks like this outcome 3 is on here twice, or I'll leave them separate for right now. You can get like terms together and call them 2 times the probability of outcome 3. So I have 0.15 and 0.15. So 0.3 if I add those together. So if I subtract that from the other side, 1 minus 0.15 minus 0.15 is 0.7. And so this, if you got like terms together, you can divide by 2. But let's say even if I didn't get like terms together, you can see I have 2 of the same things adding up to 0.7. So what do those 2 things have to be? Well, they must both be half of 0.7, so 0.35 and 0.35. And this isn't the only way to do this. You can put stuff in different orders and that kind of thing. So if I know these 2 are the same, I have to add to 0.7, and then I can check at the end, make sure this actually adds up to 100%. So 0.3 plus 0.7, and O2 and O3 are the same, and this one is 0.15. So just whatever information they tell you. So whatever information they tell you, you just plug in as you go. So that's part A. And now we'll try part B. So similar information, but they're starting out with a slightly different premise. So same question, I want to know at the end of it, I want all of these filled in. What's the probability for all 4 things. Accidentally put an extra one there. Okay, so what do we know? This same stuff from the beginning. So I know that probability of outcome 1 is 0.15, so I'll just plug that in right away. And they also told me outcome 3 is 0.22. So instead of outcome 3, I'll put 22%, 0.22. Okay, so I still have 2 unknowns, this one and this one. I could get some of the stuff on the same side of the equation if I wanted to, like maybe I'll subtract 0.15 from both sides. So the probability of outcome 2, 22% minus 15% is what, 7%? So if, say later, if I figure out outcome 4, I know that the probability of outcome 2 is 7% more than the outcome of probability of outcome 4. Okay, so I should plug in some of the stuff I know from here from the answer to begin with. So this one is 0.15. They already told us that. And then they told us that this one is 0.22. So it's only these 2 I need to figure out. Okay, so what's the only piece of information I haven't used yet? Well, I do know that if I add up all the outcome probabilities, they have to add up to 100% or 1, just universally, right? If you flip a coin, it's 50%, 50%. If those are the only 2 things that can happen, 50%, 50% better add up to a probability of 1. Okay, so from here, let's fill in all the stuff we know. We already know this one's 0.15. We already know this one is 0.22. And then I don't know the probability of outcome 2, but see how this whole thing is equal to the probability of outcome 2? So instead of putting this, I could replace it with this because they're the same as each other. That's what an equal sign means. So I know that probability of outcome 2 is 7% plus outcome 4. So I'm replacing this with this. Why would I want to do that? Well, notice now I only have 1 unknown, just this probability of outcome 4. So I got it all down to 1 variable, basically. Okay, so if I get some like terms together, 15 plus 0.15 plus 0.07, so 15% plus 7% is what, 22%? And then plus 22 is 44%. And then I have 2 of these probability of outcome 4, so I can do 2 times, right, like terms just like x plus x is 2x. So this plus this is 2 of these. This whole thing is just your variable. You can use x too if it bothers you to usually just leave it in this notation so you can tell which one is 1, 2, 3, 4. Okay, so I can subtract the 0.44 from both sides. So 1 minus 0.44 is what, 0.56? And then if I divide both sides by 2, right, because I'm saying 2 times this is 0.56. So half as much, so 0.56 divided by 2 would give me the probability of outcome 4. So once you get it down to 1 variable, you can solve for that 1 variable. So 56% divided by 2 is what, 28%? So we just figured out outcome 4 is 28%. And then I could come back here. I know that outcome 2 is 7% more than that. So what's 7% more than 28 is what, 35? And then especially since we had to go through solving in a couple different places, one really good check is let's make sure this adds up to 100% or to a probability of 1. So 5 and 5 is 10. This adds to 10, so I end up with 20. So I'm carrying like the 2. So 3, 4, 5, 6, 7, 8, 9, 10. Which means carry the 1. So it does add up to a probability of 1. So that's a good check at the end to make sure if you've got them all filled in. So we use the original premise they gave us, and solve for the ones we didn't know, and we check to make sure that our whole sample space adds up to a probability of 1 or 100%.